Hello friends, myself Dattatreya Jadhav. I am from XII College, Karad. Today we are going to discuss one important theorem on integration. Okay, integration by parts. Here is the theorem on integration by parts. Okay, when in the integration means integrand is a product of two functions and here two functions are different, then we use integration by part theorem. Okay, the theorem says that if u and v are differentiable functions of x, if u and v are differentiable functions of x, then look at here, integration of u into v dx is equal to, first as it is, u as it is, integration of v dx minus inside the integration d dx of first, means d dx of u into integration of second v dx. And where is the dx again, since two integrations are there, so two dx are there. Okay, look at here, if u and v are differentiable functions of x, then integration of u into v dx means product of two functions. Okay, here u is a first function, v is a second function. Then we find the integration of u into v dx as, take first function as it is, u as it is, into integration of second function, that is the integration of v dx. Okay, minus inside the integration, here is the bracket, derivative of first function, that is derivative of u with respect to x, into integration of v dx, bracket complete dx. ओके, साध्या आणि सोप्या भाषेत सांगायचं झालं तर इंटिग्रेशनच्या आतमध्ये जर प्रोडक्ट असेल दोन फंक्शनचा, तर आपण इथं इंटिग्रेशन बाय पार्ट्सचा रूल यूज करणार आहे. इंटिग्रेशन बाय पार्ट्स काय सांगतोय, हे फर्स्ट फंक्शन आहे, हे सेकंड फंक्शन आहे, तर पहिलं तसंच दुसऱ्याचं इंटिग्रेशन मायनस इंटिग्रेशनच्या आतमध्ये पहिल्याची डेरिव्हेटिव्ह, दुसऱ्याचं इंटिग्रेशन. ओके, इट्स व्हेरी क्लिअर. नाव हियर इज द प्रूफ ऑफ द इंटिग्रेशन. प्रूफ. Okay, we remember this proof by three steps. Okay, first one is let, I can write here let, second one is consider, and third one is by definition. Okay, now first one is let, consider that integration of that second function, consider the integration of v dx, integration of v dx is equal to another variable w. Okay, integration of v dx is equal to w, it's our equation number first. Therefore by, yes, integration of v is w, so derivative of w is v, so dw by dx is equal to v, it's our equation number second. Okay, look at here, in RHS there is first term is u and second term is integration of v dx. First term is u and second term is integration of v dx, means u into w is there. So consider d dx of u into w. Why we consider d dx of u into w? On RHS there is a product of, first term is product of two functions, u into integration of v dx, that is v is nothing but integration of v dx is nothing but w. So I can take here d dx of u into w. We know that derivative of product is, yes, the derivative of product is derivative of u into v is first as it is, derivative of second plus second as it is, derivative of first. Okay, which is equal to first as it is, u as it is, derivative of second dw by dx, plus now w as it is, derivative of first, that is du by dx. Look at here, but from equation second we write dw by dx as v so it becomes u into v plus w into du by dx. Here in LHS, ddx of u into v, u into w as it is. Look at here carefully. Derivative of u into w, this function is this. So integration of this function is u into w. Okay, we know that. Look at here. If ddx of f of x is equal to g of x, then we say that integration of g of x dx is equal to f of x. Okay, similarly happen here. Ddx of u into w is equal to u into v plus w into du by dx. Okay, so I can write this as, yes, or taking integration on both the sides, or by definition of integration, what we write, u into w is equal to integration of u into v plus w into du by dx with respect to x. Remember here, we take integration on both the sides. Integration of ddx, integration and differentiation are inverse process of each other, so they get cancelled, and what's remaining here, u into w is equal to taking integration on both the sides. So here integration of that term u into v plus w into du by dx with respect to x. Okay, now look at here on RHS. Yes, there is a addition inside the integration. So separate, yes, separate what? Integration sign. Therefore, u into w is equal to integration of u into v dx, u into v dx plus integration of w into du by dx with respect to x. Okay. Now here we have to find in LHS integration of u into v dx, and here is that term. For that I can write this as, or using equation first in this equation, what is w? W is nothing but integration of v dx, so I can put the values of w. U into w is integration of v dx is equal to integration of u into v dx as it is, plus integration of, writing du by dx first. Okay, du by dx first. U into v is same as v into u, so writing du by dx first, and integration of second means w as second. W is nothing but integration of v dx. Okay, into dx. Now just simplifying for integration of u into v dx. Okay, therefore integration of u into v dx is equal to, okay, u into integration of v dx as it is, and take that term on LHS. Okay, when we take this term on LHS, plus becomes minus integration of du by dx into integration of v dx with respect to x. Hence the proof. Okay, remember this theorem is used when the integrand is product of two different functions. Okay, when integrand is product of two different functions. And remember this theorem as, look at here, this is our first function, this is our second function. Consider u as a first function and v as a second function. Here first as it is, integration of second, okay, minus inside the integration, derivative of first, okay, derivative of first into integration of second. Okay, remember this theorem as first as it is, integration of second minus inside the integration, derivative of first into integration of second dx. Okay, we use this theorem for integrand is product of two functions. Okay, now there are three notes: first, second, third. Okay, there are three notes. First note is make the proper choice of first and second function. Okay, make the proper choice of first and second function. First function is, okay, in which first function is differentiable and second function is integrable. First function is differentiable and second function is integrable. Second, if the function is product of two functions, first function can be select or choose as the function which appear first in the letters of the word liat. Letters of the word liat, where L stands for logarithmic function. L stands for logarithmic function such as log x. Okay, I stands for inverse function. Inverse function, yes, sine inverse x, cos inverse x, tan inverse x, sec inverse x, cosec inverse x, cot inverse x. A stands for algebraic function such as x, x square, x cube. Okay, T stands for trigonometric functions such as sin theta, cos theta, tan theta. Okay, and E stands for exponential function such as e raised to x. Okay, जर तुम्हाला इंटिग्रेशन मध्ये जर प्रोडक्ट ऑफ टू डिफरंट फंक्शन्स दिलेला असेल तर तुम्ही फर्स्ट फंक्शन सिलेक्ट करायचं आहे ज्यामध्ये पहिल्यांदा या लेटर मधला वर्ड येईल ते फर्स्ट फंक्शन असेल. L म्हणजे लॉगॅरिथमिक, I म्हणजे इनव्हर्स, A म्हणजे अल्जेब्राइक, T म्हणजे ट्रिगोनोमेट्रिक आणि E म्हणजे एक्सपोनेन्शियल फंक्शन. अँड थर्ड नोट इज while finding the integration of logarithmic and inverse function, while solving the integration of logarithmic and inverse function, if second term is not given, then consider that second term as 1. Okay, only in the case of logarithmic function and inverse function. If second term is not given, then consider that term as 1. Okay, I can revise this theorem again, integration by parts. If u and v are differentiable functions of x, then we say that integration of u into v dx is equal to u into integration of v dx minus integration of d dx of u into integration of v dx. We remember this theorem by these three steps: let, consider and by definition. Okay, let integration of that function in RHS, integration of v dx is w, therefore dw by dx is equal to v. Consider d dx of, second step is here, consider d dx of u into w using product rule, first as it is into derivative of second plus second as it is derivative of first. Okay, and by definition of integration, taking integration on both the sides, u into w is equal to integration of u into v plus w into du by dx. Okay, so we get here integration of u into v dx is equal to u into integration of v dx minus integration of du by dx into integration of v dx. Okay, now we solve here some examples on integration by parts. Okay, here is the first example on integration by parts. Evaluate integration x into e raised to x. Okay, clearly it is example on integration, so denote first the integration by I. Let I is equal to. Okay, now look at here the word liat, L-I-A-T-E. Tell me, here x is which function? X is algebraic function. And e raised to x is which function? It's exponential function. But algebraic comes first. Algebraic comes first in the word liat. So first function is x. So x is our first function and e raised to x is our second function. On integrating by parts, we know the formula for integration by parts. I can write here again, integration of u into v dx is equal to u as it is integration of v dx minus inside the integration derivative of u, that is du by dx, into integration of v dx. Okay, this dx is for integration of v, and for that integration here is again dx. Okay, or you may can remember this formula as पहिलं तसंच दुसऱ्याची इंटिग्रेशन, मायनस इंटिग्रेशनच्या आतमध्ये पहिल्याची डेरिव्हेटिव्ह दुसऱ्याचं इंटिग्रेशन. ओके, हियर फर्स्ट फंक्शन इज x, so put x as it is into integration of second function, that is e raised to x, minus inside the integration derivative of first, that is d dx of, put bracket there, d dx of x into integration of second, that is e raised to x dx, bracket complete, write dx again for that integration. Okay, so here is the formula used in our example, which is equal to x as it is integration of e raised to x is again e raised to x minus integration of d dx of x is 1 into integration of e raised to x is e raised to x dx, which is equal to x into e raised to x minus integration of 1 into e raised to x is e raised to x dx, which is equal to x into e raised to x minus integration of e raised to x is again e raised to x, so e raised to x plus c. Taking e raised to x common, it's x minus 1 plus constant of integration c. Here is the answer of the first example. Integration of x into e raised to x dx is equal to e raised to x into x minus 1 plus c. Take another example. Second example is here. Evaluate integration of log x. Evaluate integration of log x dx. Okay. Now some students are saying that integration of log x is 1 upon x. Remember, derivative of log x is 1 upon x. Integration of log x is not 1 upon x. And some students are confused in these formulas. Look at here. Clearly it is an example on integration. So first denote the example by I. So starting with let I is equal to. Okay. Now here second function is not given in the integrand. And we know the point, if second function is not given in logarithmic and inverse functions, take second function as a 1. So I can write this as integration of log x into 1 dx. Okay, here log is logarithmic function and real comes first. So first function is our logarithmic function and 1 is our second function. Okay, now using integration by parts says that first as it is integration of second minus inside the integration derivative of first into integration of second. Okay, I can write first as it is log x as it is into integration of second, that is integration of 1 dx, minus inside the integration derivative of first d dx of which term, it's log x, derivative of log x into integration of second term is here 1, so integration of 1. Okay, bracket complete and write the dx here for that integration. Log x as it is, tell me integration of 1 is x minus integration of derivative of log x is 1 upon x into integration of 1 is x dx. X get cancelled and this can be written as I is equal to x log x minus integration of 1 dx, which is equal to x log x. X get cancelled here. X log x minus integration of 1 is again x plus c. You write this as x into log x minus 1 plus. Okay, this is the final answer of the given question. Next, here is another example. evaluate integration x into sin x. Evaluate integration x into sin x dx. Okay. Here, inside the integration, there is product of two functions, x into sin x, and these two functions are different. So we solve this integration by parts. Okay. Now choosing first function is which. Okay. Now here x is there. X is which type of function? X is algebraic function, and sin x is trigonometric function. Look at here. A comes first here. Algebraic function comes first. Okay, and trigonometric comes after A. Okay, so I can choose x as a first function and sin x as a second function on integration by parts, or on integrating by parts. By parts says that first as it is integration of second minus inside the integration derivative of first into integration of second. Look at here. First function is x. X as it is integration of second function, that is sin x minus integration of derivative of first d dx of x into integration of second, that is integration of sin x. Okay, bracket complete. Write dx again. Why? Because this dx is for that integration sign and this dx is for that integration sign. Okay, so here is x into I is equal to x into integration of sin x is what? Minus cos x minus integration of derivative of x is what? X is what? 1 into integration of sin x is what? Minus cos x. 1 into minus cos x dx. Okay, x into minus cos x is minus x cos x minus integration of 1 into minus cos x dx, which is equal to minus x into cos x, minus minus becomes plus integration of cos x dx, which is equal to minus x cos x as it is, minus x into cos x as it is, plus integration of cos x dx. Integration of cos x is sin x plus constant of integration c. Here is the answer of third question. Integration of x into sin x. Integration of x into sin x is minus x cos x plus sin x plus constant of integration c. Okay. Moving to our next example, evaluate integration of x square into log x. X square into log x. Okay. First denote the given integration by I. So starting with let I is equal to integration of x square into log x. Look at here. In integrand there is a term x square into log x. X square means algebraic function and log x means logarithmic function. But here what happened? Here comes first in the letter lag. Okay. So first function is our log x and second function is our x square. So writing this as log x into x square dx. Okay, this is our first function and x square as a second function. On integrating by parts, here we use on integration by parts since there is a product of two functions. First as it is log x as it is into integration of second. Second is what? X square. Integration of x square dx minus integration, inside the integration, put bracket there, derivative of first, that is d dx of, first function is what? First function is log x, so derivative of log x into integration of second function, that is integration of x square dx, okay, with respect to x. By using this rule, integration by parts, integration of u into v dx is equal to u into integration of v dx minus integration of du by dx into integration of v dx. Okay, so which is equal to log x as it is. We know that integration of x raised to n is x raised to n plus 1 upon n plus 1. So integration of x square is x raised to 3 divided by 3. Okay, minus inside the integration derivative of log x is 1 upon x. Okay, into integration of x square is x cube divided by 3 dx. Okay, this dx is for that integration get cancelled. Okay, when we take the integration of x square, which is equal to, this can be written as x cube into log x divided by 3 minus, here 3 is constant, 1x get cancelled, 3 is constant, that is 1 upon 3 is constant, take outside the integration, what's remaining here, x square, integration of x square dx. Okay, which is equal to x cube into log x divided by 3 minus 1 upon 3 into, again we find here integration of x square. Integration of x square is x cube divided by 3 plus constant of integration c. On simplification we will write this as x cube into log x divided by 3 plus x cube divided by 9 plus constant of integration c, or you may can take common x cube divided by 3 from both the terms and solve it. Okay, so here is the answer of the integration of x square into log x dx, which is equal to x cube into log x divided by 3 plus x cube divided by 9 plus constant of integration c. And here is the last example on this type. Evaluate integration. Evaluate integration x into tan inverse x dx. X into tan inverse x dx. Look at here, clearly example on integration. So denote this integration by I. Let I is equal to integration of x into tan inverse x. Here integrand is product of two functions. Which two functions? X into tan inverse x. First function is x, second function is tan inverse x. Now we have to select the first and second function by proper choice. Okay, x means its algebraic function, tan inverse means its inverse function. Look at here, in the word Liat, inverse function comes first. So here is tan inverse x is our first function and x is our second function. So I can write this as tan inverse x into x dx. It's our first function and x as a second function. Okay, now integrating by parts. Here for by parts, on integrating by parts, what is the formula for integration by parts? First as it is into integration of second minus inside the integration derivative of first into integration of second. Okay, which is equal to first as it is. First means tan inverse x as it is into integration of second function, that is integration of x dx, minus inside the integration derivative of first, derivative ddx of first function is tan inverse x. Okay, into integration of second. Integration of second means integration of x. To complete this sign, write dx here. Okay, bracket complete, again write dx here to complete this integration, which is equal to tan inverse x as it is into integration of x is x square divided by 2. Okay, by using integration of x raised to n. Integration of x raised to n is x raised to n plus 1 upon n plus 1 minus inside the integration derivative of tan inverse x is 1 upon 1 plus x square into integration of x is x square divided by 2 dx. Okay, which is equal to x square into tan inverse x divided by 2 minus, here 2 is constant, take common from integration, that is taking 1 upon 2 common from integration sign, inside the integration there is x square divided by 1 plus x square dx, which is equal to x square into tan inverse x divided by 2 minus 1 upon 2 into, look at here degree of numerator is 2 and here degree of denominator is also 2. Degree of numerator is 2, degree of denominator is 2, means it is a improper fraction. To find integration of improper fraction, we convert that improper fraction to proper fraction by actual division or adjustment. I can simplify this by adjustment method. Here denominator is 1 plus x square, adjust denominator in numerator. So I can write here 1 plus x square. What happened? In numerator there is only x square. but I add here 1. To maintain equality, I subtract here 1. So numerator x square can be written as 1 plus x square minus 1, and put bracket for denominator adjustment in numerator dx, which is equal to I is equal to x square into tan inverse x divided by 2 minus 1 by 2 into, look at here, integration denominator gets separate, 1 plus x square divided by 1 plus x square, it's what, 1 plus x square divided by 1 plus x square, it's 1 minus 1 upon 1 plus x square on separating denominator, which is equal to x square into tan inverse x divided by 2 minus 1 by 2 into, inside the integration there is what, inside the integration there is subtraction, so separate integration symbol, integration of 1 dx minus integration of 1 upon 1 plus x square dx, which is equal to x square into tan inverse x divided by 2 minus 1 by 2 into, tell me integration of 1 is x minus integration of 1 upon 1 plus x square, whose derivative is 1 upon 1 plus x square, it's tan inverse x. So integration of 1 upon 1 plus x square is tan inverse x plus constant of integration c. On multiplying by 1 by 2, we write this as x square into tan inverse x divided by 2 minus x by 2, minus minus becomes plus tan inverse x divided by 2 plus c, or take 1 upon 2 common from all these terms. Okay, so today in this video we see integration by part. Okay, thank you.